On a few occasions throughout this course so far, I've used common table expressions, or CTEs, as a way to generate a temporary result set that can be used in a more complex query scenario. In this video, I'd like to talk a bit more about CTEs and how they differ from temporary tables. CTEs are sometimes referred to as with queries because of how they are declared in your SQL using the with keyword. CTEs must be created at the start of your query, beginning with the with keyword, and then, if you need multiple CTEs for your query, each subsequent CTE can be created by simply adding a comma after the preceding CTE, then opening a new set of parentheses to start the new CTE. We demonstrated this in week 2 when we examined cross-join operations. You can also alias all of the columns in your CTE using this handy little trick. After the name of your CTE, but before the as keyword, insert a pair of parentheses, then list how you want each column to be aliased, with each column name separated by a comma. If you list fewer columns than are actually returned by your query, then the CTE will return the original column name of the table that you specify. But if you put in more columns than your query will return, you will get an error message saying that the with query has 6 columns available, but you've specified 7 columns. One of the key differences between a CTE and a temporary table has to do with the scope in which it exists. A CTE can only be created within the context of a larger query, so we can say that the CTE is scoped to a single query. In practice, what this means is that you can't just create a CTE in one query and then run another query to reference that CTE. If you try to do this, both queries will return an error. For instance, running this CTE on its own will cause an error because there is no outer query, which is required when working with CTEs. Conversely, running the outer query on its own will also fail, and hopefully the reason is obvious. We're asking this outer query to return some data from the crew CTE, but we haven't created the crew CTE. The query is looking for something that doesn't exist. So in order for this to run correctly, we have to run the entire SQL statement from the CTE through the outer select, and that returns a correct result. Now contrast this with a temporary table, where we can actually create the table in one query and then reference it in another query. To demonstrate, I'll highlight the create temp table script here and run it, and then I'll go down and run the select star from temp table in a separate query, and I get the correct result. This is because the temp table exists beyond just the context of the current query that we're running. Temp tables exist for the life of the session. A session is a connection between an application and the relational database. In our case, sessions are the connections we make between pgadmin and the Postgres database, and each query tool tab that we open in pgadmin represents a different session in the database. So if I create a temp table in one tab and then open a second tab in which I try to query that same temp table, the second query will fail because my second tab or second session cannot see the temp table that I created in my first tab or first session. In very complex SQL scripts, this can actually give temp tables an advantage over CTEs because they can be created and then used and reused throughout the session until the session is terminated. CTEs, meanwhile, continue to exist only in the context of a single query. Another benefit of using a temp table is you can add indexes on a temp table. An index is a type of object we can add to tables in our database, which contain keys that are built from one or more columns in each table. Each index's keys are stored in a structure known as a B-tree, which allows the database engine to find rows in your tables more quickly and efficiently. All of the tables in our DVD rental database have indexes on them, except for the custom ones that we've created ourselves. Now is a good time to mention that we will not cover how to create and manage indexes in this course, but I want you to be aware of their existence and why they are important. If you want to learn more about indexes, there is some optional reading at the end of this unit. Indexes are a key component of good database design because of how they can improve performance of the database, particularly when it comes to finding and returning row data. And this is where temp tables have that advantage over CTEs. I can't put an index on a CTE, but I can put one on a temp table. For example, if I was to load up a temp table with a huge amount of data, like hundreds of thousands or even millions of rows, taking the time to put an index on that temp table can yield performance benefits for my queries that could save valuable time, many seconds or even minutes, when I execute the queries with that temp table. Temp tables with indexes can be very advantageous over CTEs, especially when dealing with large amounts of data. That being said, most of the time I prefer to use CTEs instead of temp tables because CTEs are quicker and more easily disposable.